Thank you. So many of the earlier speakers were talking about PFAS chemistry and mobility. I'm going to be looking at a broader issue, looking at PFAS in environmental samples and the sources of PFAS to our environment. Next. So here's a brief outline of what I'll be talking about. First, again, environmental samples. PFAS in freshwater fish, anadromous fish, bird eggs, and then the Maine farms. That'll be followed by a discussion of sludge and septage. Now, I can just see you kind of cringing when I say those words, but even though sludge is denigrated quite a bit, it has a critical role in our water purification, water quality system, and it'd be good to appreciate that. Then I'll talk about PFAS sources, both from residential homes and also from industries, and end the talk with a discussion of our new PFAS study, which begins in the spring of 2021. Thanks. Next slide. So let's start with fish. All contaminants eventually end up in the water, and the long food webs you find in aquatic systems exacerbate the exposure to chemicals that biomagnify. Many of the PFAS analytes do that. So first, let's discuss the fish tissue action level for PFAS here in Maine. It was updated in 2016 based on new reference values coming out from EPA. It is right now set at 34 parts per billion for the sensitive population. That's for children under the age of 8, women of childbearing age, and at close to 80 parts per billion for the general population. There is no federal action level for PFAS. Each state sets its own level. Maine's action level is toward the high end of the range. The only states with higher levels are Alabama and Oregon. And the state with the lowest action level for fish is New Jersey, which has reduced its action level to 3.9 parts per billion wet weight. So that's about at least an order of magnitude lower. And that's for both the sensitive population and the general population. So keep those numbers in mind as we talk about these fish concentrations. Now, most of the fish work done here in the state has been done by DEP's SWAT program led by Barry Mower, who I have to say is spending his first day of his official retirement in an all-day webinar looking at PFAS issues. Thanks for your work, Barry. And in 2015, they looked at PFAS concentrations in several fish species in 5 rivers here in the state. And they sampled downstream of sewage treatment plants. In most of those sites, fairly low levels were found in the fish tissue, and these were composite samples of 3 to 5 fish. But in the Mousom River below the Sanford sewage treatment plant in both 2015 and 2016, levels were found in white perch and in largemouth bass that exceeded the fish tissue action level for the sensitive population. In DEP's report, they speculated that because of the large outflow effluent volume from the sewage treatment plant in relationship to the size of the river, that may be a reason for these high levels. PFAS was also looked at in fish near the Loring Air Force Base back in 2013. They found really remarkably high levels in brook trout. Brook trout tend to feed low in the food web and generally are cleaner fish than other species here in the state. Now, these levels of PFAS would be there we go. These levels of PFAS would be justify fish consumption advisories, except there are already existing fish consumption advisories near the Loring Air Force Base, a do not eat warning for fish because of PCB levels, and then they're covered under the statewide mercury consumption advisory for the more sensitive population to only eat 1 meal of brook trout per month. Next. So here we have, oh, interesting. Here we have information on PFAS in anadromous fish in the Penobscot River. This is a collaboration between the Penobscot Indian Nation and EPA to look at the levels of contaminants in fish that are moving up the Penobscot to spawn further up in the watershed. And that seems to have turned into all, numbers are still legible, so we're going to go with this. A couple things to note for this chart. Going along the top here, I've ordered the PFAS analytes moving from the shorter chain P4 polyfluorobutyrate, moving all the way up on the far right to the decanoic acid. Whoops. And my chair just went down. Let me see if I can get that up. There we go. Couple other things to look at. The fish are ordered from the bitrophic level with striped bass, predatory, piscivorous fish at the top, sea lamprey next. Those are fish that consume the blood and some flesh of other species. Then the alewife, herring, and shad, which feed our planktivores. It's useful to note that PFBA was found in the greatest number of species. This is the same PFAS analyte that Jean MacRae found dominated her samples of food waste. Kind of curious. Note that those with a sulfur head, PFASA and PFAS, here both C8 length chains were found in fish higher in the food web, and that the sea lamprey had the greatest range of PFAS analytes of the species looked at. Also note, American shad, both their tissue and their roe had very similar PFAS concentrations. That's it. Next. Now, back about 15 years ago, BRI had the foresight to look for PFAS analytes in bird eggs as part of a larger study they were doing looking at contaminants in bird eggs across the state. And the map on the right shows their findings from 2007. Note that the highest concentrations were found in the piscivorous fish, the osprey, the cormorant, and the bald eagle. Note that these ranges change with the with species, so that the colors don't mean the same thing for different species. One bald eagle down in Casco Bay area had, or at the mouth of the Kennebec, had over 700 parts per billion wet weight in the eggs. Comparing that with the lowest observed adverse effect level for PFAS in whole eggs, which ranges between 8 and 100 parts per billion, that's wicked high. Belted kingfisher had almost 1,000 parts per billion PFAS in their eggs. In 2008, over 60% of the loon eggs here in the state were above this low-al. In 2009, 75% of the osprey sampled in Casco Bay were also above the low-al. So looking at this, you can see that the fish concentration levels were generally low that we have information for right now. But there were some individual sites where concentrations were elevated in the fish. And it also, it depends on what fish tissue action level you're using when you're comparing the levels that have been found to date and looking at their potential toxicity. In loons, or in birds in general across the state of Maine, from this 15-year-old study, we found really high levels of PFAS. But PFAS has also been withdrawn from production here in the US, starting in the early 2000s. We'd expect those numbers to be coming down now, 15 years later. Whether they are or not is still uncertain. Next. So let's move on to farms. Now, Norman earlier today already spoke about the Stone Ridge farm down in Arundel. So this is just a quick rundown. It was identified from contaminated well water collected somewhere between 2013 and 2015. The PFAS concentration in milk by late 2016 was very high. This 1,400 parts per trillion of total PFAS in milk, compare that with the action level for milk established by the state of 210 parts per million. By January 2017, you already saw a map of the high PFAS levels in the soil. Note that I've had this, these data are for the soil moved up to parts per billion range. By May 2017, PFAS and PFOA were detected in surface water. And then by June 2019, both Fred Stone, who's the man standing here, he's the farmer, and his cow, that's Lida Rose, but Fred and his wife had their blood tested for PFAS and found it to be around 100 parts per billion. Background is around 10 parts per billion across the state. Next. And here's another shot of the Tozier farm near Fairfield. In June of 2020, so 4 years after Fred Stone's contamination at his dairy farm was identified, then another farm showed up because of DEP testing of milk. When they went and tested the milk from this individual farm, they found really unbelievably high levels of PFAS in the milk. And subsequent testing of wells identified over 55 where the well water exceeded the state action level for PFAS in well water, which is 70 parts per trillion. Some wells had up to 28,000 parts per trillion. Amazing. Next. So let's talk a little bit about sludge application to these farms. Sludge was identified as the probable source of the PFAS contamination on both farms. As Norman discussed this morning, the Stone Ridge farm had a mix of paper mill sludge and sludge from 2 sewage treatment plants. The Tozier farm had sludge applied again for 30, 35 years. Early on, it received sludge from the Kennebec sanitary treatment facility, which also processed the industrial waste from the Hudamaki molded paper facility near that site. And then in between 2006 and 2015, the Tozier farm also received waste sludge from Soil Prep. Now, Soil Prep is a company that composted sludge from 9 different towns' sewage treatment plants and put that into, combine that with septage from, so the solids moved out of septic tanks. And also there was a mention of sludge being imported from out of state. It's hard to tell from this where the actual source of contamination to these farms came from. There's some hints though. Next. So let's talk about some wastewater history here. Before the 1970s, the waterways in Maine were in bad shape. They received raw sewage. They smelled bad. There were gloppy solids lining the shores. No one wanted to go near those rivers. The Penobscot River was no exception. The 1972 revisions of the Clean Water Act provided both federal mandate to clean things up that was allowed the state to move forward with work that they had already begun. And also it provided funding. So using the plant in Brewer, Maine, that plant came online in 1975. 80% of the cost of that plant was paid for by the feds. It provided secondary treatment using an activated sludge process. It is designed to remove more than 85% of the BOD, the biological oxygen demand. That's the amount of oxygen that would be needed for organisms to degrade organic material discharged into the water, and also remove over 85% of suspended solids. The plant was designed to treat 5.6 million gallons per day because it would be processing wastewater from both the town of Brewer and also from the paper mill that used to operate there, Eastern Fine Paper. The paper mill has shut down. Now the plant's operating at about 1.8 million gallons per day, but it's still producing over 4,000 cubic yards of sludge. But that's sludge that's not going into the Penobscot River, which is a good thing. Yes, next. So let's talk about sludge. The domestic sewage is high in nitrogen and phosphorus. As Jean discussed, our food, our waste has a lot of nutrients in it. The typical nutrient level is just great in sludge. Nitrogen, phosphorus, potassium, all things that are critical for plant growth, that are limiting plant growth in water bodies. So you want to remove those from the effluent. They have to go somewhere. They're an element, so they go into the sludge. And but in addition to those nutrients, it's not all sweetness and light. There are also toxic contaminants. This list here is of the maximum concentration of a range of trace metals that can be found in sewage sludge that cannot be exceeded if you want to get an exceptional quality classification for your sludge. Next.
2 minutes, ma'am.
Okay. And there's also, what about PFAS? PFAS is not regulated. Were it not for the Safe Drinking Water Act that monitored unregulated contaminants every 5 years and that looked for those contaminants back in 2013-15, we may not know that this problem exists here in the state. So that's a curious thing. Next. So where is all this PFAS coming from? Our coats, a study done in Sweden found that up to 0.7 tons of fluorinated molecules are released from all of the breathable rainwear worn by people in Europe if they're only washed one time per year. That's a huge amount of fluorinated contaminants entering the wastewater, being taken out by the sewage treatment plant and going into the sludge. There's personal care products like shampoo and sunscreen. You're thinking, why would there be PFAS in shampoo? Well, it repels oil. And who wants oily hair? So there. Cleaning supplies. Floor waxes are a prime source of PFAS. There is a school here in Maine where the well water is contaminated. It is thought this well water is related to the use of fluorinated floor wax on the gym floor. And then there's food content materials. Those clamshell paper, folded fiber clamshell containers that we now use, some of those are impregnated with PFAS. and they are disposable. So it's a one use, and then the PFAS is going into the environment. Ski wax. Oh my gosh. There are ski waxes with PFAS in it to make your glide better. A study done by Gail Carlson down at Colby College found PFAS contaminants, especially the long chain analytes, in the snow next to a collegiate cross-country ski race that matched the same profile of PFAS in the wax itself. And then there's industrial wastewater. Paper mills can use PFAS to coat the paper, and I've already discussed paperboard itself for takeout containers. And then there's the firefighting foams. Next. So what are we going to do about it? The folks listed here on the PFAS research team have joined together with funding to look at management options for PFAS contaminated sludge. It's myself, Onur, Apul, Jean MacRae, both from, who are speaking today, both from UMaine, Caroline Noblet, who is with the School of Economics and will be looking at the risk perception of PFAS here in the state. It's been in the news a lot. What do people really think about it? How can we better inform the public about the possible threats? And John Peckenham, the former director of the Water Research Institute at UMaine, who has been studying this issue for years. We're working together with a PFAS stakeholders group that has a wide range of perspectives, from Ned Beecher, who leads an industry group, the Northeast Biosolids Research Association, Chris Evans, who's been working on PFAS for years with Maine DEP, Mark Hutchinson from Cooperative Extension to provide the agricultural perspective, and Patrick MacRae from Defend Our Health, a nonprofit based down in Portland, looking at environmental health issues. Next. We have a really ambitious goal for this project. We're beginning with a summary of what is known about what's done with this sludge right now, and then working with our stakeholders, we'll be identifying other management alternatives, other ways that we can deal with the sewage sludge. And then this is really the heart of the issue, looking at the environmental outcomes. Are we reducing PFAS exposure to humans in the environment? What's the technical feasibility? And we'll be depending on Onur and Jean a lot for this section. You know, can, if the sludge is landfilled and it moves and the rainwater falls on the sludge, it moves down into the bottom, will the effluent from that landfill then be contaminated with PFAS? What can be done there? If you put it back into the sewage treatment plant, it just cycles right through again. And then looking at the economic and societal costs and the public risks of perception. Next. So there we are. There is a lot of work to be done on this issue. As always, research leads to better policy. Thanks for your attention.